Before we end for the day, I want to bring up something that I think raises a crucial point. Next week, we're going to start something a bit different than what we've been doing in the last several weeks. It's critical that geologists are knowledgeable about more than rocks and the structure of solid matter, and I'm going to explain why, aside from the obvious reasons, that is, with an interesting introduction to next week's lesson. Perhaps you're already familiar with the mysterious phenomenon moving rocks. These huge rocks, some of which weigh 100 pounds, sit on the floor of a desert in California called Death Valley, which is surrounded by mountains. And the rocks move around the desert floor, which is evidenced by the trails, like tracks, that are left in the sand behind them as they move. No one has ever seen it happen, so there isn't a solid explanation regarding how they move across the floor of the dry lake bed. While there are several theories, we know for sure that humans are not moving them, as there are no footprints, tire tracks, nor is any heavy equipment being used to move them. So how are they moving? The first theory is wind. The majority of the rocks are moving in the same direction as the dominant wind pattern, southwest to northeast. So some researchers theorize that it could be super strong windstorms that are moving the rocks from one place to another. However, they all move in different patterns, in straight lines, zigzags, and big circles. What could be causing this? Another theory is that it's the wind and rain combined. The desert floor is clay and it's dry, but sometimes it rains and the clay becomes very slippery, and this makes it difficult to walk on, let alone stand on. It is in these wet, slippery conditions that some scientists think that the rocks can be pushed across the desert floor. But there's a major flaw with this theory. In an attempt to test this theory and determine the force of wind required to actually move the rocks in these conditions, a group of scientists flooded a piece of the desert floor. To their amazement, they discovered that winds of at least 500 miles per hour are needed to move even the smallest of the rocks. Winds of this force have never been recorded on this planet. So that's settled then. There is one other possibility: ice. The desert gets so cold at night that it is possible that the ground could become covered in a thin sheet of ice. The idea is that the rocks would also become covered in ice, and the wind could then push them across the icy ground. But the question is, can the wind really move ice with rocks in it? Not only that, but theoretically some rocks would become frozen in the same chunk of ice and be moved together. But it appears that the rocks that have moved have all ended up on their own, having taken separate routes.